KE Lab, Part 2, Data and some calculation hints. Again, we're going to work through these calculations in class, but I'm going to give you some hints so you can get a start. And let's take a look. This is just the amounts here. This is page number 90, I believe. Yeah, bottom says page 90 down here. And we are looking at the milliliters of 0.0020 molar Fe plus 3, and we always used 5 milliliters. And that's straight from the data table on the previous page. Okay, and then we changed the amount of SCN minus or KSCN. It was still 0.0020 molar, but we progressively went from 1 to 2 to 3 to 4 to 5 to 6. So we kept the Fe plus 3 constant, and we gradually increased the concentration of SCN minus. And what that resulted in is these transmittances. So notice there's a lot of black dots all over the place, but this is just a decimal, 0.82, 0.67, and so on. I think you can distinguish that. Notice transmittance got less or absorbance increased as there became more SCN in this stayed constant, which makes sense. Increased reactant, increased the product, making the transmittant less or the absorbance more. How do you figure out the absorbance? Use the same formula for absorbance you did in part 1. Here's a quick look back at it. I think, trying to scroll to a quick look back. And let's try again. Here we go. It is right here. Absorbance equals a negative log of T. And again, do the log not as a percent, but as a decimal. And then 0.69 would be there. All right, I'm just looking at a little, be careful with the data table. Notice this 0.82 is not a percent, it's actually 82%. And then I already put it in decimal form here. So apologize for that. So the percent would actually be 82%, and then I put it in decimal form. Okay, go back and calculate your absorbance. And then, oh, what about this? So I've kind of changed these steps A through N. And what did I do? Instead of going from moles and then to molarity, I just did it all in molarity and used a dilution factor. So if I were doing solution 1 and I had 5 of this and 1 of this, I'd think, oh, it's 5, 6. But be careful because there was some HNO3. So going back to the data table for part 2 on page 89, notice there was always 10 milliliters in this container. 5 plus 1 plus 4, 5 plus 2 plus 3, and so on. So I would say 5 out of 10 milliliters were this. So I go through the dilution factor of 5 over 10 for the iron. For the KSCN, I'd go with the dilution factor 1 over 10. So be careful to get the right dilution factor when you do that step. And that would help you find the initial concentration of Fe plus 3 and the initial concentration of SCN minus. The final concentration of FeSCN plus 2, you're going to find by looking at your absorbance and comparing it to concentration using your calibration curve from part 1. So that's how you're going to get this data piece. And then these really get canceled out with our shortcut. But what's going to happen is notice these are the concentrations of the SCN and the Fe plus 3, but this time at equilibrium. So you're going to have to do an ice box for each of these to figure out what these are right here. Once you have those and you have all your values, you can plug everything into this equation and figure out the KE. And you're going to do that for solutions 1, 2, 3, 4, 5. Ideally, they'd all be the same. They may not be. Think about it like when we did the rate constant in the reaction rate lab. And if they should come out the same or not. This time, we're not looking at fictitious data, we're looking at real data. So we'll see what happens with that. Just a couple hints, calibration curves, you're gonna end up drawing that line or curve. All those things are not gonna line up perfectly. I'm looking at the data you have, so do the best you can. 0, 0 is a valid point, so I would run it through 0, 0, and then do the best you can from there. The other thing is make sure you have the calibration curve in part 1 done coming into this, and watch the videos. I guess you're watching them right now. And then we can work with these calculations here and make sure you're getting the right KEs, or we'll see what we're coming up with in class. All right, Wednesday, 12 to 12:30. I think if you have any questions, we can do that. Otherwise, see you in large group on Thursday at 12:22. Thank you.